discrete time system has an impulse response h of n. The system is here. Statement A is stable. See, if we check the stability condition for the given h of n, the summation means it has to be absolutely summable, means the summation of h of n must be less than infinite. See, h of n is not equals to 0 for n is greater than or equal to minus 3, whereas 0 n less than minus 3. Here h of minus 3 is nothing but 0, h of minus 2 is minus 1, h of minus 1 is 0, h of 0 is 1, h of 2, h of 1 is 0, means the samples are going to be repeated in this way. 0 at the 0 instant the magnitude is going to be 1, at 1th instant the magnitude is going to be 0, 2, means if we take the absolute summation of all these samples, it is going to be 0, which is a finite value, hence it is going to be a stable. It is stable. If we check the causality condition, means in order to check the causality, the condition is h of n must be 0 for n less than or n less than 0. But it is not true, because h of n is non-zero for n less than 0 too. Hence it is non-causal system. See, if we want to check the memoryless condition, means what? The h of n has to depend only on the present value of n. But here, if we take h of n is 0, we will get cos 0 u of 3, which is depends upon the future value of the input. Hence it is memory system. So it is a stable system. Hence option A is correct. Question is integral minus 4 to 2 cos of 2 pi t del of 2t plus 1 dt. Here 2t plus 1, assume x. So 2 dt equals to dx. So dt equals to dx by 2. If t equals to minus 4, x equals to minus 8 plus 1, which is equals to minus 7. T equals to 2 means x equals to 4 plus 1, which is equals to 5. Here t equals to x minus 1 by 2. So if we substitute all these values into the equation, so we will get minus 7 to 5 cos of pi x minus 1 del of x dx. This is 1 by 2. Here this total summation equals to, suppose from the property, if it is a b sum f of x del of x dx equals to f of 0 if a less than 0 and b greater than 0. So if we use this delta function property, we will get 1 by 2 cos of pi, which is equals to minus 1 by 2, and answer B is correct. The filter corresponds to given h of n is. See, in order to check the what kind of filter it is, we need to convert h of n into the frequency domain, that is h of e power j omega equals to summation h of n e power minus j omega n. Here omega is the digital frequency, that is the range of omega is minus pi to pi. So h of e power j omega equals to 5 e power 5 plus minus 4 e power minus j omega plus 3 e power minus j2 omega plus 2 e power minus j3 omega. So if we substitute omega equals to 0, then we will get as 5 minus 4 plus 3 plus 2, which is equals to 6. If we check e power at highest frequency, that is j pi, 5 plus minus 4 e power minus j pi plus 3 e power minus j2 pi plus 2 e power minus j3 pi. Here 5 e power j pi is minus 1, hence it is 5 plus 4 e power j2 pi is plus 1, this is plus 3. 3 pi is minus 1, it is minus 2. So it is 5 plus 4 9, 9 plus 3 12, 12 minus 2, it is 10. So h of e power j0 is less than h of e power j pi. It means it is working as a high pass filter, hence option C is correct.
Has given a three-phase four-wire system. Okay, three-phase four-wire system is possible only with star type of connection. Okay, delta is not possible four-wire connection. Okay, now let us take this is a three-phase four-wire system, R phase, Y phase and B phase. Okay, now he has given a three-phase four-wire system. Look at the rating he has mentioned here, 400 by 230 volts. What does it mean that? Does he give two different supplies? No, he has not given two different supplies there. Okay, what does it mean that he has given a line voltage as 400 volts and this line to phase voltage, that is line to this neutral voltage, which is equal to 230 volts. Okay, line voltage is 400 volts, phase voltage is 230 volts. That is what this representation means. Okay, a lamp of 100 watt is connected to one phase and neutral. Now this is one phase and neutral. Let us take lamp 1 is connected between these two. Rating is 100 watt. Okay, similarly lamp 2 is connected between another phase and neutral. So this is lamp 2 with rating of this lamp is 150 watt. Okay, if accidentally this neutral wire is opened, then what is the voltage across lamp 1 and lamp 2? Okay, when neutral wire is present, okay, we can find resistance of lamp 1. Okay, lamp is connected to between one phase and neutral earlier when neutral wire is not opened. Okay, what is the rating of the lamp? 100 watts. So resistance of the lamp is V square by P. Okay, V square is phase to phase voltage, 230 square by P is 100. You will get it as 529 ohms. Similarly, resistance of lamp 2 is, it is connected between another phase and neutral. So voltage phase is 230 volts by P is 150 watts. So this is 352.66 ohms. Now if neutral wire is disconnected, okay, these two lamps are connected between two lines. Okay, so sum of voltage, that is VL1 lamp 1 and VL2 is equal to line voltage 400 volts. Okay, now what is VL1 here? Total voltage is 400 volts into, okay, just like a voltage division rule, 529 by 529 plus 352.66 ohms. Okay, you will get BL1 as around 240 volts. Similarly, VL2 is equal to 400 into 352.66 by 529 plus 352.66, which is equal to 160 volts. Okay, so option C is correct answer.